Hi, everyone. Thank you for joining us today. This is our third webinar in our webinar series that we're hosting as part of our space architecture competition. Today, our speaker is Leszek, who is the CEO of Lunaris, which is an analog station based in Poland. He's also the founder of Space is More. So thank you, Leszek, for being here.
Thank you for having me. I know that last year I also had a talk, I guess, about analog habitats for your audience as well. But this time, the main focus are the analog habitats. So this is the competition. This is all about the competition is all about creating a proposal for such structure, isn't it? Or
yeah, it's about creating like an architectural design for an analog space station to be based in Jordan in Wadi Rum. But yeah, we had for those of you who did not participate last year, we also had a webinar series last year with Leszek and Lunaris. And we actually got to go inside the space station, and the crew showed us around.
Yeah, I think it was like that. That's true.
Yeah, we got to see how they make the food and grow the plants and everything. So we can also share the recording from last year with the participants because it was really interesting.
Awesome. And today I have a presentation. It could be similar to the one that I showed you last year, but now it's a bit more condensed, and I hope it will be a nice amount of knowledge and inspirations for participants. If you would like me, I can simply share my screen, and well, or there are some questions I need to answer first. I don't know.
No, actually, I would like to ask the participants to send their questions in the messages, and we're going to answer them at the end of the session. But before we start, I just want to thank the Moon Village Association for helping us host this webinar series. And I would also like to thank Glavki, who is hosting today's session. So you can start now, Leszek. Thank you.
Thank you very much. Okay, so I will share my screen. I hope we can see my presentation. So yes, the name is quite straightforward. We will be looking at different habitats, analog habitats around the world. But first, we need to know the story, or the main thing, what is analog research. And the story begins in 1969 when Jacques Piccard, a famous explorer that already went to Mariana Trench, wanted to was organizing yet another expedition, underwater expedition, this time traveling at the bottom of Golfstrom in the Atlantic. He wanted to go with the flow, let's say, and together with 4 more people. And it happened almost the same time as Apollo 11, and Bernard Brown that approached Jacques Piccard to add one of his engineers into the crew. So this researcher could observe this crew of Ben Franklin submarine that would travel for 1 month, because Bernard von Braun thought that it's a very good analog situation to a future long space mission. So people isolated on a very small space underwater. So it was named the first analog study because you could simply use the fact that there was another expedition in extreme environment on a very small space, and you could observe how people behave. So it was a crew dynamic investigation, basically. And they started their journey at 6 days, or a few days before Apollo 11. So and both expeditions started from Cape Canaveral, or maybe not from Cape Canaveral, but from Florida region. So at that time, people were exploring both moon and bottom of the oceans. That was quite interesting week or month or time period. But those kind of analog studies also were they were continued it was a Cold War. So no, we are not at the Cold War yet, because this is the chart of total pressurized volume per crew member of different spacecrafts. And at that time, Apollo lunar module and Apollo command module had roughly like a 10 meter meter squared per crew member, maybe even less. And then researchers tried to know what is your performance limit, what is the smallest volume you can put your astronaut in, and they will still perform well. And that's why they were doing those investigations with submarines. So now there's only like 2 or 3 underwater habitats operational in the world, but we'll go to them. But this is, I simply wanted to stress that NASA was trying to translate the volume of the spacecraft to floor plan of the underwater habitat, for example. So they know how much floor they need to give to their underwater research in order to simulate this 3D space in zero G. And so yeah, that was how it started with Ben Franklin. In Soviet Union, there were experiments that focused on isolating a small group of people in biosphere, and that it already was it had more focus on growing your own food. So it was more focused on being sustainable somewhere underground. So it was almost investigation in long-term nuclear shelter, but it was something that was definitely a good analog for future space missions that still don't grow their own food, but soon probably it will happen. And in 1987, the Biosphere 2 was constructed and by private investors, and it wasn't an investigation done by a national agency. It was a private endeavor that planned on isolating 8 people for 2 years in this simulated environment with deserts, marshes, oceans, savannas, rainforests, and some agricultural area to see if people could be sustainable off-world. It's a whole story how it went. It's super interesting, but if you want to know, but this is not the scope we are looking for, because we are thinking about smaller habitats that would simulate those first capsules that will be put on the moon or on Mars. But this is super interesting to investigate. And just recently, like 7 years ago, analog mission simulations finally received some sort of definition, and this definition was written in Mars Reference Architecture 5.0 addendum, second addendum, and it stated that analog mission simulation is an activity designed to represent specific scientific, technical, and operational aspects of the future space mission using actual or functionally representative systems and operations or procedures under analogous environmental conditions for the purpose of understanding performance and interactions among the systems and operations or procedures, as well as their ability to achieve mission objectives. It's one long sentence, but in fact, if you get into it, it's really it's representing very well what analog mission is. It's or analog mission simulation. It allows you to investigate different aspects of space mission. It could be technological aspect, it could be scientific one, it could be operational one, and how they interact with each other. So, for example, if we go back to Ben Franklin mission, it was like a separate scientific expedition, and that that researchers could use to test certain scientific or operational aspects of the potential space mission. But now, like space agencies or research institutions are organizing a dedicated space analog mission simulations that are simulating also this scenario of being on the moon or Mars. So it's not done during some another scientific expedition to some extreme environment. This is all part of the simulation. And for example, European Space Agencies is doing their Pangea analog mission simulations in Lanzarote. This is geological workshops for astronauts that they are learning how to operate prototypes for sample gathering, for example, but many other things when it comes to operational aspects of potential future EVAs on the moon. ESA is also trying to create their own Luna facility that will not be in some analog environment like Lanzarote. It will be a big hole with a simulant of lunar regolith, and they will perform a lot of experiments there. Sometimes ESA is using Concordia Station in Antarctica. Obviously, Concordia Station is an Arctic base that is conducting their own studies, but it's a good analog situation for gathering data on group dynamics between people that are spending their time there. For example, they're left there for winter. And in Moscow, in the Russian Academy of Sciences Institute of Biomedical Problems, there is a Mars 500 facility. Well, the mission was called Mars 500, where they simulated the whole mission to Mars. That lasted a year and a half, a little bit more. Independent organizations are creating their own projects, their own habitats, their own and their own science. So in 2001, MDRS was created in Utah by the Mars Society. High Seas in Hawaii. Those are very good examples of habitats that are located in some extreme environments, and they could be used as an analog for some geological studies. There's a wonderful habitat in Israel, the Mars, that hosted MED 20 by Astroland Space Forum. And even now, there is one analog mission happening in Iceland. It's Chill Ice 2. This is the photo from the last year. And during Chill Ice expeditions, they're bringing their expandable habitat with them. They're putting it inside a lava tube, and they're spending the whole week in this simulated scenario. So those are the examples of independent facilities or programs that are conducting interesting studies, and they are using this analog environment or some extreme environment to do that. But there are also other types of habitats. So this is what NASA is doing, HD or Hera now it's called. First, it was put in on the desert for Desert Rats program, and now it's located inside a research institute. They're performing a lot of tests for orbital analog missions. So if people are close there, they're simulating a spacecraft basically. And in fact, I guess there's a mission happening there now. DRAS program. There were field studies. We could say that they were a bit like a Pangea on steroids because of those wonderful rovers and analog spacesuits. There's Aquarius Reef base that is used both by ESA and NASA. It's located near Florida, and this is currently the biggest underwater habitat that is used for those analog tests. And now NASA is finishing building Marsden Alpha. This is a 3D printed analog habitat that is also located inside a research facility. So it's located in stable laboratory conditions. You can see that it's slowly, in this picture, it's slowly printing its walls. The layout is, it could be more similar to what you could see on Earth, but it's a nice test for technology when it comes to 3D printing. And then it will be used for a 1-year-long mission for analog astronauts. I guess it should start this year, like at the end of this year, or maybe sometime next year. So in my study, I recognize that there are different types of analog habitats, and they are constructed differently. They are taking into consideration different aspects of research. So I call them analog habitats, adapted habitats, prototypes, and environmental control and life support systems experiments. And I will show you some examples, and we will try to see what is the difference with each one. But there's something important that we should mention, because some of those analog habitats, especially analog habitats, are spaces designed to serve certain functions and to serve certain purposes, but are not, in fact, in many cases, technological prototypes of a future base that or something that could put on a rocket and then go with it to Moon or Mars. And some of them, like prototypes, are in fact focused on having the testing the structure or some structural elements, integration subsystems, and so on. So some of them are focusing even on developing their technology readiness levels. So to the point where you are at the very beginning, you are looking for basic principles, then you are trying to create a concept, but then you are trying to create prototypes and put those systems together, and then you can and at the very end you can get a flight proven system, so a habitat that could go to Moon or Mars. And some of those habitats are focusing on just that. Some of those habitats are using off-the-shelf technologies, very simple ones, to simulate space, put equipment there, and, for example, observe people in there. And so you can already see that there could be different aspects or different angles of designing those laboratories, let's say. So that was technology readiness level, like the original one. There is also one created for mockups for those kind of space-related spaces. It only goes from 1 to 6, because TLR 6 for mockups is a system that is ready to be tested in relevant environment, but it still won't go to space. It's a mockup. So probably most of the analog habitats are somewhere on this scale, and some of them are in fact on somewhere on habitation readiness level. So they're prototypes where you are first designing it, then you are testing it in full scale, then you are testing it in some test field. It should be pressurized, obviously, then flight qualified, and then there's flight proven. So it's not, and most habitats are not going that direction, because they are in fact tools in order to investigate some aspects of the future habitats that they will need to include in this process of creating an actual flight proven system. Okay, so in 2001, MDRS was created, and it's probably the longest running program currently, with many missions each year, and it has you can see that it's It's a cylinder, but it also has a twin station. It's a flashlight Arctic Research Station, and there and inside they have 2 levels. One level consists of airlocks, your toilets, sinks, showers, EVA preparation room, so extracurricular activity preparation room. This is where you keep your simulated spacesuits, your workshop or your biological area. So this is your work area and your airlocks. On the upper floor, you have your galley, your dinner table, and your rooms. So this already separates your working space for your private space. And we will see how much space such unlocked habitat gives per person a bit later when we go through all of those habitats. Similar example here of such a habitat is the Mars in Israel. You should check it out. They got very nice expansion last year while working with Austrian Space Forum. And also High Seas is another example of that kind of unlocked habitat that is located in some remote area and is using off-the-shelf technology. So here you can see geodesic dome, and when you look at the floor plan, you have an entry here, an open space where you have your workstations, your kitchen, your dining, your lab, and your and your toilet. And when you go up, you have an entresol with your private bedrooms. So this is how it looks. So you can already see that it's not a technological prototype of a moon base, but it's or Martian base, but it really gives opportunity to put every single needed function there and to study people there and allow them to perform their tasks, their missions, and their investigations. So it's a very nice way to create the full program for analog habitat without going to some crazy costs of developing the whole technological prototype. Okay, another example of habitat that is okay, because High Seas is located on a volcano in Hawaii, and there's also lava tubes. Another habitat in the lava tube is Astroland in Spain. I guess it's a cave. It's not lava tube, but still a similar setup. Although this one is inside the cave, it's quite new. They started before the pandemic, and now they're developing quite nicely. And it's quite nice to work with them. So I cannot wait for some upcoming missions in here. What they will come up with. And then there are isolation facilities. I already mentioned Mars 500, and those are modules where people lived for quite some time. Habitation module with 6 rooms, small galley, and a dining, and a common room, a medical module, and utility module that had all their supplies for the mission, but also a gym. And those 2 other modules. This is a Mars lander that allowed part of the crew, upon simulated arrival at Mars, to go there, simulate descent, and then walk on the simulated Mars surface for a few days, and go back. And they were able to. They had to go back all the way back to Earth. But this is as isolation facility, so it's not located in any extreme environment. Isolation itself is this extreme condition, but also it's a laboratory condition that allows you to replicate the same scenario or the same conditions over and over again. This is how it looked inside. There is a very good reason why it's all in this wood. It was all about having a material that will react well to outgassing, because this space is pressurized independently from the outside. There is our facility, Lunaris. We'll go definitely in depth on that one. After we'll go through other facilities, but this is also an isolation facility on a former military airfield, and another good a new one, isolation facility is SAM, that is created at the Biosphere 2 in Arizona, and we visited it like half year ago. It was awesome. So me and Shaba were going around and we were quite excited to see that yet another great facility is being created in US. I will definitely check it out once it's open. But yeah, the analog community is definitely growing, and there are some great projects to observe. When it comes to adapted habitats, sometimes science is being done on Halley 6. It's a British Antarctic Station, and it's a quite nice design because it was designed by very renowned studio, and you can see it's definitely a large scale scientific setup or base, but it's nicely laid out. You can see that here you have your sleeping modules and combat modules. So this is where it's basically your quiet area, your private area. Then you have your common module that where is the kitchen, where you are basically socializing with people. Then you have two generating rooms that are separated by a bridge that you really need to go outside and go to the other modules that are science modules. So you really need to go out to work. It's definitely taking into consideration that mentally you would like to have this separation. In MDRS, you saw that something is on the bottom level, something is on the upper level. Here you have to physically go outside in a very harsh weather to do some science. This is how this social module looks like, or how it was visualized. I guess it looks a little bit different after it was built. Another place where people are doing experiments, and in those examples, obviously there is a expedition that is doing science in Antarctica, and this is a perfect opportunity to do some investigations along the way for example, crew dynamic, some sociology of isolation, and so on and so on. And this is the same what is happening in Concordia Station. It's a station built by France and Italy, and it has like those two 3-level towers, and one is quiet tower where you have your hospital, your crew quarters, your laboratories. So the work is, so it's not that you are separating your work from your private space. It's about being quiet here, and the other one is noisy tower where you have your generators, your cinema, your gym, and your dining room. So there are different ways you can try to organize your life, being in a closed and separated scenario. I mentioned Aquarius. This is how it looks inside. You can see that it had some updates recently, and this is the plan. Bunk beds. In fact, there are 3 bunk beds on each side, so 6 people can fit there. Then you have your living space, like the counter, your table. So this is where you are doing your everyday like meals and so on. Then you have your science area with toilet, and then you have wet porch where you can go underwater. So this is how it looks like. And quite recently, in fact, I guess they are also starting a mission just now. In Czech Republic, there is Hydronaut. You can also, and you should look how they're developing and what they're doing now, because I guess their new mission starts already started a few days ago, something like that. But it's definitely worth to check out. I need to visit them because like Czech Republic or Czechia is not far from my home, so I will definitely do that when I have some free time. I've mentioned Hera before, but those are the prototypes. Now we are going to prototypes, and inside Hera you have well, in fact, 2.5 levels of because one is your main area where you do science. There you also have your hygiene module and airlock. You go up and there is your living level, let's say, with your gym, with your dining, with your communications, and then there's also some space to go on the ladders and to four little let's say almost rooms that where you sleep inside. But this is a quite nice setup that tries to put all the systems together in a and connect them. So it's a nice example of the prototype that tries to integrate different systems. Another one that is being, I guess, still developed is Hestia. So this module is a bit bigger than Hera, has 3 full levels and 1 stowage level, and you can see that it is also it is a pressurized vessel. So this is something that could potentially fit inside a rocket fairing and could be transported somewhere. So this is definitely a prototype, and you can see what is on each level. So on entry level, when you have your airlock, you have your spacesuits, your exercise, basically your laboratory. So this is your work level. The second one are your 4 cabins for your crew, so your private space. As you can see, I guess it's prepared for 0G because people are definitely sleeping in the vertical configuration here. So that's what I am definitely getting from those drawings. And then you have your galley and command center. So as always, there's an attempt to distribute your work and your living from one another. Okay. Obviously, in Europe we have She Habitat. It's a nice concept already. It's a prototype that could already fit on 2 of those modules in on one of the rockets, and there and you can then expand them and create a bigger station. It could be also probably envisioned as some kind of laboratory for some areas that suffered a disaster somewhere on Earth, but the main purpose was to introduce this modular architecture for a small Moon or Mars habitat. And it's really quite small. It can host two people inside with their small, let's say, rooms, a small lab, a small hygiene compartment, a small galley, and a life support system. So its main purpose or focus was to fit those sections on a very small space, and that it's a very, very interesting project. Those are a few photos here. And in Germany, there's Mamba, so Moon and Mars based analog. Once again, it's a cylinder, so it simulates a pressure vessel, and it was an attempt, very good attempt to fit or to redesign a laboratory for Moon and Mars conditions. And this is how it could look like if you added more modules and already on the moon. So this is an artist vision here. In fact, it's our artist vision because we we made some visuals for them, and yeah, and then there we have those environmental control and life support system experiments, and those have very different angle because they focus on large-scale food production. So we can already imagine that the space is dedicated for plants and their growth rather than for human needs. And you can see this is a Moon Palace one from China. There are 3 modules here. One is a small module for people with 4 small rooms, galley, and a shower, and then you have 2 bigger modules for growing the plants. So you can already see that there is a different research angle. They're giving all the space to this biological life support system that they try to create. Yet another experiment from China did almost like it's very similar. This is the space for the crew. This is the space for plant cultivation. Yet another visualization, because I really have hard time finding if this is the prototype of this project. In research papers, they're showing those two photos next to each other. There is an ISS designed by the designers of She Habitat, so by Liquifer Systems Group, and it's located near Neumayer Station in the in Antarctica. And this module is dedicated for growing plants. So it is also an investigation into life support systems and plant growth. So here you don't have space for humans; they're living in an Antarctic station, but still, you can see that there is some space for growing. There's some service section for preparing all the seeds and soil workstation, and then you have main entrance. We can go back to the BIOS experiment from the 70s, because this is also something that we could consider life support system experiment. And then I try to put all those habitats in on our map. In fact, there's quite an amount of them already. There are not all of them. I missed the North Dakota University habitat, but it's really interesting to see as well. And there are several more different habitats, but you can see there is quite a lot of them on this map already. So and maybe we will soon see yet another one somewhere here. Okay, so now let's see how they differ from one another. So I put their volumes and their floor plans and amount and the number of the crew members for each one of them, and see what I would get, in fact. So and in the end, I was looking for floor plan per person and volume per person. And what I saw is that analog habitats have between 27 or 29 square meters per person, and around 85 to 95 square meters per person. You usually have like 6 crew members. So those spaces are quite big, and they're designed quite to fit this bigger crew, but it benefits, for example, research in crew dynamics. So you need more space, but you also have a bigger crew. And it's hard to tell anything about adapted habitats because they are used for their own expeditions, investigations. But when you are using them, you're mostly using them for human factor studies for most of the time, some operational studies as well. When it comes to prototypes, their floor plan is between 12 and 24 square meters per person, and their volumes are from 33 to 64 meter cubed. So, and the crew is around from 2 to 4 people. It's basically due to the fact that you are optimizing your space and your structure to fit on the rocket. So you're thinking about this system integration, structures, ergonomy, and space logistics. So this is what they're focusing on, and this is why they're nicely optimized. But then you cannot fit as many people there. So you will get basically different data from true dynamic studies, for example. And then you have those life support system experiments, and they are the bigger. They're the biggest from the whole bunch, because you are they're going up to 140 meters cubic meters per person, but it's due to the fact that in fact you are not giving the space to your crew, but for growing plants. Although if you think about it, obviously that only means that you will need to have that much space to have a sustainable presence anywhere, because you will need to feed them as well. Okay, and now I can show you a bit more about our facility, how we designed it, and how we are running our experiments here. So we are located at a former military air base in a center of Poland, in a city called Piła. And there when we came there, we found those hangars, those bunkers. There's a lot of concrete there, so it's really almost like a nuclear bunker for planes, because they were designed to withstand a blast, and they were obviously designed during the Cold War in case of World War III. And we decided to change this place to an analog research facility, and we are using one of those hangars to create our extravehicular activity area. So over Moon or Mars, there is like 400 tons of sand and basalts, and this is where people are going, wearing those analog suits and using rovers, studying human-robot collaboration. It's 300 square meters, so it's quite big. But next to it, there is your research station. I mentioned before, it's an isolation facility, so there are no windows, and you are isolated there for the time of the analog study. Usually it's 2 to 3 weeks, but soon enough we will be doing a bit longer investigations as well. Okay, some photos from the EVA area, and yeah, and now a close-up for the habitat itself. So it's made up from shipping containers. So as you can see, it's off-the-shelf solution that allows us to organize the space and functions in a way we envision it. So at the very center, there's an open space we call an Atrium. So this is a place from where you can go to other modules, but also it's used for socializing, for group projects, for sports and so on. But from there, you're going to those designated modules. So your workshops, a gym, your office, your small dormitory. So everyone has their own. It's like a small capsule hotel. Everyone has their own small capsule. So you do not have your separate rooms here. But when we are doing those short simulations, so short isolation missions, we try to make it a bit more extreme. So you have very little private space there. Then you have your kitchen with the storage, your cultivation module and biolab, and then hygiene module. So obviously, place where you are showering, where you have all of your water supplies, and we are doing some investigations into water savings. Yeah, and other photos showing how that looks like. As you can see, it's not a sci-fi movie set, but it's a very basic setup for us to observe, to monitor, and we are not only monitoring like the video live video feed, but every single module we are observing measurements from other modules. What is the temperature, humidity, CO2 levels, how much power they're using, how much water they're using. So and we are able to monitor quite a lot of things during the simulation. And during the simulation, obviously, crew can only contact us directly. Sometimes we are only using text messaging for certain investigations. Okay. Yeah. And when you think about analog missions, it's all about people that are isolated inside our habitat. And from very beginning, we decided that we want to analog missions allows you to test new things, to see different angles, and see what human spaceflight will look like in the near future. So we always knew that we want to test different crew compositions. And from 2017, 2021, oh no, now I need to think about 2022. So we already had 24 missions with 120 participants. And when it comes to male-female ratio, it's around 50-50. This is something that was always important for us. But when it comes to nationalities, obviously we are in Poland, so 42% participants were Polish. Around the same amount, around 35% are from the rest of the Europe. 15% are from US. There's quite a big representation of Mexican analog astronauts in our facility. But what is quite important here, since it's a facility that it's not in a remote area, not in an extreme environment, it's a very good opportunity for younger participants to test themselves in this controlled but isolated environment. So for many people, it's their first step in analog missions. That's why we have like quite a big representation of younger audience there. But we also had people that were closing to 60 years old, and usually try to mix younger people with some more experienced researchers and analog astronauts. Analog missions allows for testing different scenarios, and in 2017 we did an Icarus 1 mission, and we invited a very good engineer that suffered a major accident a few years back, and he was rendered both blind, and he was missing an arm. And so it was a simulation what would happen to the crew if someone got hurt. Obviously, this person was very well adapted already to live with their disability already, but it already showed what would happen not only to the mission objectives, but also to crew dynamics if there was a person that needed more attention. And it was very well received, in fact. Our researchers presented it on Extreme Medicine Expo 2 times. Recently, the crew published an open letter in Science magazine, because disability in space is in fact something that could be a game changer to many people. But also, this paper, in fact, was mentioning something that people call hyperability instead of disability, because you can imagine that if someone has, for example, no limb, they're using less oxygen and they need less calories. And if we are talking about, for example, a leg, you will not lose muscles in a zero-G environment. This is probably why ESA is doing for astronauts feasibility projects, where they are inviting people with disabilities to their astronaut corps. Okay. I would love to mention that during one of our missions, we had Sian Proctor on board. Later last year, she went to space with SpaceX on Inspiration 4 mission. So, and for us, it was extremely inspiring, and it was wonderful to see that people that really their focus is to become an astronaut are also using those analog missions to as their test fields, as their to gain more experience. Because we definitely are not training astronauts; we are doing science. But people that are coming here are either researchers or students or people that are aiming very, very high. And we can mention Sarah Sabri. She was also on our mission last year, and she went to space last month, I guess, on Blue Origin rocket. She was the first Egyptian to fly to space, and well, I am now I think we will have. I hope we will have more people like this in the near future. So I guess I will end with that, and we could go to potential questions. How about that?
Yes, thank you, Leszek, so
Awesome.
much. That was really interesting. So yeah, if anyone has any questions, please send them in the chat. We don't have many participants today.
No worries.
But we always share the recording with the participants, so maybe they can watch it later if they're not able to attend.
Sure. So I would say, so I will ask my own questions for me.
Okay.
What I would try to focus on while designing analog habitat. So I would both focus on the design scope. So probably I would like to know what scenarios will be investigated there. That would already tell me what kind of space I would like to have. So what is the crew? What is the number of the crew members there? How are we more focusing on, for example, human factors, something that is that you need space and people to do, but you don't need like a lot of equipment that can come later, obviously. Or you are focusing on maybe on the biological end, and you are in fact investigating sustainable ways of living in a extreme environment. And this is something that definitely could be interesting for developing in the region that you are in. The other thing is I would seek how to make it cost effective, because some of the best habitats currently were made with a lot of effort, but not especially large sums of money, for example. So having a good idea how to create your space, if it's not a prototype, is super important. So those are the things I would think about. So the scenario, so the science that you want to do, it will define, in fact, what do you need inside. And the other thing is your budget. How do you would like to approach creating space in a remote area that well needs to function and needs to be brought there, and so maybe some mobile solutions could be also taken into consideration. Who knows? Okay. Jude, what do you think? Because we are hitting 1 hour mark.
Yeah, I don't think we have any questions. If anyone would like to speak, you're also welcome to do that. If you would like to ask your question verbally, you can also do that. Just raise your hand, and I can unmute you. but yeah, it doesn't look like they have any questions. So yeah, I guess we can just end the session. Thank you so much, Leszek. It was really interesting and informative. And yeah, because our last session was about space architecture for outer space, so this is more relevant to what the participants are designing. Maybe one last question would be, would you recommend any resources?
Resources.
Yeah.
It's always great to go to spacearchitect.org page. There are tons of great papers on not only space architecture but also analog habitats as well. So this is a great repository for anyone that is seeking knowledge. So yeah, that's the one probably. Yeah, so that's the answer probably. The other thing is there are some I guess you can find them on YouTube, some online lectures that can teach you new things about analog research or space architecture, obviously. But well, everything is there on the internet, and space architecture, I guess it's a great place to start. Okay.
Yeah, that's it. Like I said, we didn't have any questions, but we have a message from Muhammad. Can you see it? Were you able to see it?
Yeah, I do not have a question yet, but I would like to say that it was a very, really an interesting presentation. Thank you. Thank you, Mohammed, as well. It was, I had fun presenting to you today. And well, I hope to soon, I hope to see designs from the competition. That's something that really interests me the most now.
Yeah, thank you so much, Leszek. You really helped a lot. Yeah, thanks. Have a nice day.
Have a nice day. Thank you very much.
Yeah, bye.